Your phone buzzes, your electric vehicle hums, the F-35 thunders overhead, a silent sentinel in the skies. What do these marvels of modern engineering, these pillars of our connected, advanced world, all have in common? They share a dirty little secret, one that most people never even think about, much less understand. Without 17 nearly unpronounceable metals, they turn into expensive paperweights. Seriously. We're talking about the fundamental building blocks of almost everything high-tech, from the screens we stare at to the weapons systems that defend nations. And here's the kicker: China now holds the master key to this entire kingdom. Week by week, sometimes day by day, Beijing decides who gets those metals and who doesn't. It's not just about mining, it's about control, leverage, and a quiet, decades-long strategic play that's now paying massive dividends. So, stay with me, because what you're about to see isn't just about rare metals. It's about the quiet takeover that already rewired the global economy. And in the next 20 minutes, we're going to uncover how it happened, why no one stopped China, what it means when a single country controls the elements that power our entire way of life, and why every government on Earth is scrambling, almost desperately, for a plan B. Welcome to Empire Secrets. Let's clear up a common misconception right off the bat. Rare earths aren't actually rare. That's probably the worst branding decision in geological history, right up there with calling Greenland, Greenland. These elements, a group of 17 metallic elements, including the 15 lanthanides plus scandium and yttrium, are actually quite abundant in the Earth's crust. In fact, cerium, one of the rare earths, is more common than copper. So, what's the big deal? The real challenge, the excruciating part, is separating them. Imagine a family reunion, but instead of just awkward small talk, all 17 members are chemically identical, clingy, and incredibly difficult to pull apart without an immense amount of effort, specialized knowledge, and some seriously toxic chemistry. They tend to occur together in mineral deposits, mixed in with other elements, and their similar chemical properties make isolating each one a monumental task. You can mine them elsewhere, sure. Deposits exist in Australia, the United States, Vietnam, and other places. But turning that raw ore into the high-purity oxide, then into the metal, then into the alloy, and finally into the precision magnet nestled inside your phone speaker or the advanced optics in a fighter jet, that's where the magic, or rather the industrial alchemy, happens. This process can involve up to 400 chemical baths, each step carefully calibrated, each requiring specific reagents and energy inputs. It's an incredibly complex, multi-stage industrial process that also generates a staggering amount of toxic sludge and wastewater. And that, my friends, is the moat. That's the strategic advantage China spied first, decades ago, and then systematically built into an unassailable fortress. While the West focused on the sexy, visible parts of technology, China quietly cornered the market on the dirty, difficult, but absolutely essential foundation. To truly understand Beijing's rare earth dominance, we have to rewind the clock. Picture this, it's 1978. China is just beginning to emerge from the decades of isolation under Deng Xiaoping's reforms. Deng, a visionary leader, tours the vast Bayan Obo mine in Inner Mongolia, a site that holds some of the world's largest rare earth deposits. He turns to his aides, his gaze fixed on the future, and utters what could become an economic North Star for the nation. The Middle East has oil, China has rare earths. This wasn't just a throwaway line, it was a declaration of strategic intent, a blueprint for an economic conquest. Beijing didn't just stumble into this, they planned it. They began a deliberate, systematic, and heavily subsidized campaign to control every single step of the rare earth supply chain. Think about it, they supported the digging, the crushing, the complex leaching processes, the separation, and finally, the smelting. It was a massive, whole-of-government effort, fueled by long-term vision and state-backed capital. By the mid-1990s, the results were undeniable. Chinese producers, operating with massive state support and far less stringent environmental regulations, could dump rare earth oxides into the world market at half the cost of Western competitors. It was an economic tsunami, Mines like California's Mountain Pass, once a titan of rare earth production, simply couldn't compete and were forced to shutter their operations. South Africa's Steenkamp Skraal mine followed suit. The West, caught up in the allure of globalization and cheap goods, happily outsourced the messy, polluting and capital-intensive work to China. While Western nations were tightening environmental rules, making compliance expensive and complex, China's state banks simply wrote off the massive environmental pollution bill as strategic overhead. It was a cost of doing business, yes, but a cost deemed acceptable for securing a critical strategic advantage. The long-term environmental damage was immense, but the short-term economic and geopolitical gains were even greater. By 2005, the quiet land grab was nearly complete. China controlled an astonishing 97% of global rare earth mining and a staggering 100% of the processing. Let that sink in. One nation had achieved a near-total monopoly on the raw materials and, more importantly, the know-how to transform them into usable forms for virtually every advanced technology on Earth. Game, set, almost match. And the world was about to find out just how complete that match really was. For years, the West largely ignored China's growing rare earth dominance. It was an out-of-sight, out-of-mind kind of problem, or so they thought. Then came September 2010, and everything changed. A Chinese fishing trawler bumped a Japanese Coast Guard boat near the disputed Senkaku Diaoyu Islands in the East China Sea. It was a minor incident, easily dismissed as a diplomatic spat. But Beijing's response was anything but minor. Quietly, almost imperceptibly at first, China halted rare earth exports to Tokyo. It was a surgical strike, a precise application of economic power that sent shockwaves through global markets. Within weeks, the price of NdPr oxide, neodymium praseodymium oxide, critical for powerful magnets in hybrid cars and wind turbines, quintupled. Imagine that. A 5-fold increase in price, almost overnight. Japanese auto giants like Toyota and Honda, heavily reliant on these materials for their booming hybrid vehicle lines, were forced into a panic. Production lines ground to a halt. The embargo only lasted 2 months, a relatively short period, but the message it sent resonated like a thunderclap across the globe and stuck forever. Rare earth supply could and would be weaponized. It was a stark, undeniable demonstration of China's leverage. Suddenly, terms like supply chain resilience and critical minerals weren't just academic buzzwords. Washington, Brussels, and Canberra, along with other major industrial powers, woke up to a chilling reality. They realized they were not just dependent, but utterly vulnerable. The problem, as they quickly discovered, was that they were already a decade too late. The infrastructure, the expertise, the sheer scale of investment required to build alternative supply chains couldn't be conjured overnight. China had spent 40 years building its empire. The rest of the world had spent that same time dismantling their own capabilities. The wake-up call was loud, clear, and incredibly expensive. Fast forward to 2025 and the situation has only solidified. You might hear headlines about how China only mines 60 to 70% of global rare earth ore these days. Sounds like progress, right? A slight reduction in mining dominance. Don't be fooled. That's a distraction. Because while they might mine less, they still refine a staggering 92% of the world's rare earths. And that, my friends, is the crown jewel. That's the real choke point. So how do they do it? How do they maintain such a stranglehold on processing even if they're not digging up every single gram themselves? It comes down to 3 critical factors. First movers built the pipes. Think about it. For decades, while Western companies scaled back or shut down, China was investing. They built the massive, complex chemical processing plants, the acid baths, the solvent extraction rows, the specialized furnaces. They developed the unionized know-how, training generations of chemists, metallurgists, and engineers who understand the intricate, often proprietary steps involved in separating these elements with high purity and efficiency. This isn't just about machinery, it's about institutional knowledge, embedded expertise, and a workforce that literally knows the chemistry inside and out. It's not something you can just buy off the shelf. Second, scale. China operates at a scale that's almost unfathomable elsewhere. Take Baotao, for example, a city in Inner Mongolia. It's home to some of the largest rare earth processing facilities in the world. Baotao alone can process more NdFeB, neodymium iron boron alloy, the stuff of powerful permanent magnets, than the entire rest of the world combined. This massive scale allows for efficiencies, cost reductions, and a level of output that no other country can currently match. It's a classic network effect, but for industrial processing. Third, and perhaps most critically, chemistry patents. More than 80% of the intellectual property related to rare earth separation technologies, the really clever, efficient, and sometimes less polluting ways to get these elements apart, is held by Chinese universities and state-affiliated labs. This isn't just about having the factories, it's about owning the recipes. This means even if a Western company manages to mine some rare earth ore, they might still need to license Chinese technology, or worse, struggle to develop their own without infringing on existing patents. Here's a perfect illustration of this dominance. America's flagship rare earth mine, Mountain Pass in California, which has been making a comeback, still sends its rare earth concentrate to China for final separation and processing. Why? Because there's literally no commercial scale separation plant outside of Asia equipped to handle the volume and complexity required. The translation is stark. You can dig all the rare earth ore you want in Texas, in Australia, in Canada. You can pull it out of the ground, but the real value and the ultimate choke point happens thousands of miles away, in places like Jiangxi province, where the complex chemistry transforms raw earth into the precision materials that power our world. Until that changes, China holds the ultimate trump card. But if you thought China's control was already tight, think again. They're constantly refining their game. Since July 2025, Beijing has introduced a sophisticated new layer of control, the export licensing regime. This isn't just about capping tonnage anymore, which was the old way of doing things. No, this is far more granular, far more surgical. Now China issues licenses one shipment at a time. Let's break down what this means for a company trying to get their hands on, say, terbium for a European wind turbine magnet. You want terbium? Fine, but you'll need to file forms listing your exact customer, the precise end use of the material, and, here's the kicker, the part that makes everyone nervous, any intellectual property related to the magnet design or the technology it will power. Imagine having to share your company's crown jewels just to get a raw material. It's a massive ask, a significant compliance burden, and a potential conduit for industrial espionage. And the process? It's not exactly speedy. Delays stretch from 30 to 60 days, sometimes longer. Some applications, particularly those from companies or countries that Beijing views with geopolitical suspicion, simply vanish into the bureaucratic ether. They don't get rejected, they just stop moving. When geopolitics sour, these administrative delays become a potent weapon. The result is already being felt. European auto lines are reporting stoppages because they can't get the specialized magnets they need. Spot prices for rare earths outside China are trading at 2 to 3 times the domestic Chinese quote, creating massive cost discrepancies and making it incredibly difficult for manufacturers to compete. This isn't a blunt, formal export ban, which would draw immediate international condemnation. No, this is far more insidious. It's a lever, not a ban. Surgical, deniable, and incredibly effective. China can deny any accusation of a trade war, simply claiming administrative procedures or environmental compliance checks. But the message is clear: play by our rules or your production lines will suffer. It's a masterclass in economic statecraft, turning bureaucratic process into geopolitical power. So, why don't tech companies just switch to something else? Why can't engineers simply find alternatives and cut China out of the picture? It sounds simple, doesn't it? The reality, however, is anything but. Modern technology is deeply, almost irrevocably intertwined with rare earth elements. They're not just components, they're often fundamental enablers of the performance we demand from our devices. Take your iPhone, for example. It uses at least 8 different rare earths. Tiny neodymium magnets vibrate it silently when you get a notification, eliminating the need for a bulky mechanical motor. Europium and yttrium are critical for painting those vibrant red pixels on your screen, giving it brilliant color. Lanthanum, another rare earth, gives the lens its exceptional clarity, allowing for those stunning photos you take. These aren't optional extras, they're integral to the device's core functionality and user experience. Now scale that up. Each electric vehicle motor, the heart of our sustainable transportation future, needs roughly a kilo of NdFeB magnets. That's a lot of neodymium, praseodymium, and often dysprosium, depending on the motor design. And for something truly cutting edge, like an F-35 fighter jet, one F-35 needs a staggering 417 kilograms of rare earth materials in its radar, guidance, and power systems. We're talking about sophisticated electronics, powerful sensors, and stealth coatings that depend on these elements for peak performance. What about substitution? Engineers are certainly trying. They're exploring alternatives like ferrite magnets or samarium cobalt magnets. But here's the catch: you almost always lose performance. Ferrite magnets are weaker and heavier, meaning you sacrifice power-to-weight ratio. For an electric car, that translates to less range or a heavier vehicle. For aerospace applications, a loss in power-to-weight ratio is often a non-starter. You can't just slap a heavier, less powerful magnet into a fighter jet and expect it to perform. The physics simply don't allow it. And recycling? It's a great idea in theory, but in practice, it's incredibly challenging for rare earths. Currently, only about 1% of rare earth elements are successfully recovered from end-of-life products. Why so low? Because they're used in such tiny quantities, often embedded within complex alloys and devices, making them extremely difficult and uneconomical to extract. The rest simply disappear into landfill glass, incinerator ash, or are too dispersed to be worth the effort. There's no robust, commercial-scale urban mining infrastructure for rare earths yet. The bottom line is stark. For at least the next decade, probably longer, if China sneezes, the global tech industry catches a very, very bad cold. Slowly, the realization that supply chains can be weaponized has certainly spurred action in the West. But it's a slow, arduous fight against decades of neglect and China's entrenched lead. Governments are finally putting money where their strategic concerns are, albeit with varying degrees of success and urgency. In the United States, Washington is bankrolling efforts to onshore critical parts of the rare earth supply chain. They're supporting companies like Lynas Rare Earths, an Australian miner, to expand their separation facilities in Texas. The Pentagon, acutely aware of the national security implications, is funding MP Materials, the operator of the Mountain Pass mine, to build onshore magnet plants by 2026. The goal is clear: reduce the reliance on China for processed rare earths, and crucially, for the finished magnets that go into everything, from guided missiles to electric motors. Across the Atlantic, the European Union is also mobilizing. The European Raw Materials Alliance, or ERMA, has listed 24 pipeline projects aimed at boosting the continent's rare earth capabilities. That sounds promising, right? A flurry of activity. But here's the sobering reality: only 2 of those projects have actually reached a commercial scale. The journey from feasibility study to operational plant is long, expensive, and fraught with regulatory hurdles and NIMBYism. Not in my backyard. Even Australia, a major source of rare earth ore, is looking for ways to leverage its resources without sending everything to China. They've linked a deal with Vietnam to exploit heavy rare earth byproducts from bauxite mining. It's an innovative approach, but it's small scale compared to the global demand. Meanwhile, Canadian companies like Vital Metals and Appia Rare Earths are racing against time, trying to prove they can meet just 5% of Western demand by 2028. 5%! That illustrates the sheer scale of the deficit. So if you add up every single Western project currently on the drawing board, every ambition, every government grant, you reach at best 15% of global processing capacity by 2032. Even that optimistic projection leaves a massive gap. It means that even a decade from now, the West will still be overwhelmingly dependent on China. And how does China respond to these nascent efforts? With characteristic strategic patience and financial acumen. They quietly buy minority stakes in those same Western startups, They then sit on the board, gaining insight into their competitors' strategies, technologies, and vulnerabilities. It's a brilliant, low-cost way to maintain influence, gather intelligence, and potentially slow down or even co-opt competing efforts. The fight back is happening, but it's slow, fragmented, and China is always several moves ahead. The rare earth empire isn't just an economic phenomenon, it's a deeply integrated component of their national power, driven by a whole-of-government approach that seamlessly blends economic, political, and military objectives. This isn't just about market forces, it's about statecraft at its most sophisticated. Consider the financial levers. China's state banks aren't just lending money, they're subsidizing interest rates for rare earth exporters, giving them an artificial cost advantage that Western companies simply can't match. This isn't free market competition, it's a deliberate industrial policy designed to dominate. The National Development and Reform Commission, NDRC, China's top economic planning agency, actively stockpiles critical rare earths like dysprosium during price dips, ensuring strategic reserves and influencing global markets. This isn't just speculation, it's a calculated move to secure supply and manage price volatility to China's advantage. But perhaps the most chilling aspect is the military dimension. The People's Liberation Army, or PLA, quietly but officially classified heavy rare earths as defense materials under the 2023 National Defense Mobilization Law. This isn't a subtle hint, it's a clear declaration. It means these materials are now deemed essential for national security, giving the state even greater control over their production, distribution, and export. And then there's civil-military fusion, a core tenet of China's national strategy. This means the same facilities, the same factories, the same technical expertise that make civilian magnets for your electric car or smartphone can within weeks pivot to producing missile guidance coils, advanced radar components, or stealth materials for military hardware. There's no clear distinction between civilian and military applications in this critical sector. The translation of all this is profound. China's ability to throttle rare earth exports isn't merely an economic tool, it's integrated war planning. It's a strategic asset that can be deployed to cripple an adversary's industrial base, undermine their defense capabilities, and exert immense geopolitical pressure without firing a single shot. It transforms the supply chain into a battlefield, and rare earths are the strategic high ground. So, with China holding such a powerful hand, what does the future hold for global tech and geopolitics? There are a couple of scenarios playing out, each with significant implications. Scenario A: Cold Logistics War. This is the ongoing simmering conflict we're already seeing. Washington keeps tariffs on Chinese magnets and other advanced tech components, trying to create friction and encourage domestic production. Beijing, in retaliation, doesn't impose outright bans, which would be too overt. Instead, they weaponize bureaucracy, longer license queues for exports, more stringent requirements for end-use declarations, and administrative delays that stretch for months. It's a death by 1,000 cuts. What does this mean for the global economy? Manufacturers, desperate for reliability, are forced to dual-source their rare earths and magnets, meaning they buy from multiple suppliers, often at higher costs, just to ensure continuity. This inevitability leads to an 8 to 10% cost inflation for many high-tech goods, a burden that ultimately gets passed on to consumers. Your next EV, your next smartphone, your next wind turbine, they all get a little more expensive. It's a slow, grinding economic friction that erodes margins and slows innovation. Scenario B: Straight tension hot. This is the nightmare scenario, the one that keeps policymakers up at night. Imagine a significant escalation of tensions, perhaps around Taiwan, leading to China enforcing a formal, explicit export ban on rare earths to the US and its allies. The immediate impact would be catastrophic. The Pentagon would dip into its paltry 60-day stockpile of critical rare earths, a woefully inadequate reserve for a sustained conflict. Congress would inevitably invoke the Defense Production Act, throwing billions of dollars at any promising domestic source, whether it's Californian clay, Canadian monazite, or obscure deposits in Greenland. But here's the brutal truth. Either way, whether it's a cold logistics war or a hot export ban, the decoupling process takes time. A lot of time. You can't just Photoshop a chemical processing plant into existence. Building the mines, the refineries, the skilled workforce, and the necessary infrastructure takes 8 to 12 years minimum. It's a massive undertaking that requires sustained political will, enormous capital investment, and a tolerance for environmental impact that many Western nations currently lack. Meanwhile, the demand side isn't waiting. Every forecast shows global electric vehicle demand tripling by 2030. Renewable energy infrastructure is expanding at an unprecedented rate. Defense systems are becoming more sophisticated and rare earth intensive. This means the West isn't just trying to catch up, it has to sprint just to keep its dependency ratio flat, let alone reduce it. The clock is ticking, and China knows it. The race isn't coming, the race is already on. It's happening right now, in quiet factories across Asia, in the halls of parliaments trying to allocate funding, and in the R&D labs around the world where brilliant minds are desperately searching for alternatives. This isn't just a challenge, it's a defining geopolitical contest of our time, shaping who leads the technological revolution and who is left dependent. We like to believe technology made us independent, that we built a world of limitless choice, but the more advanced we become, the more dependent we actually are, on materials we don't control, on factories we can't see, on decisions made in rooms we'll never enter. That's the paradox of progress, and it's not going away. And maybe that's the real question. If the building blocks of our entire modern world can be owned, rationed, and weaponized, what does that say about who's really in charge of our future? If you enjoyed this one, there are a few more deep dives on my channel you'll probably like. Stories about how power really moves behind the scenes. Go check them out. And if you haven't yet, hit subscribe so you don't miss what's coming next. This is Empire Secrets. Your desire, your empire.